So now let's try that with the LEDs. There are three basic types of LED illuminators currently available to our industry. A white LED created by a powerful emission of blue energy which excites phosphors to complete the spectrum, much like a fluorescent lamp. The trace looks like this. Here's our film curves again with tungsten. We can see that while the blue emission of the LED will be effectively captured by the blue sensitive layer of the film, the phosphor emission straddles the green and red film sensitivity but favors the green record. The red emission of the LED has diminished substantially by the time it reaches the peak sensitivity for the red record. So we can see how the split screen Macbeth recorded the result. Then there is the red, green, blue LEDs with a trace like this. In this trace we can see that the blue and red emission corresponds well with the film sensitivity. The green emission is off the green sensitivity peak. And then there's the multi-band approach, which employs the same white LED but is supplemented with a variety of additional devices at different wavelengths. This approach allows for a degree of tuning of the overall emission distribution. And here we can see that while we still do not have a good match for the green recording peak, we should be able to adjust the total emission to achieve a reasonable balance. Even so, that balance would not be to 32K tungsten per se, but rather to a particular film stock or digital camera. So such a light would need to be adjusted to match each particular detector. Needless to say, tungsten set to 32K will perform the same way for any detector looking at it. So, as with the fluorescence, there's not a lot of conformance between these peaks and the film stock curves, especially for green and red. So now that we've seen how difficult it is to achieve a perfect match with a discontinuous source, it becomes apparent why the use of such terms as color rendering index, the CRI, and Kelvin temperature are so hazardous. Kelvin is only relevant to a black body heated to some temperature until it incandesces, i.e. tungsten filament heated to 5,500 degrees approximates daylight, only briefly, of course, because the tungsten will have burned up by the time it gets there. But a fluorescent light with a nominal correlated color temperature of 5,500 degrees Kelvin may well not reproduce colors in the same way due to the uneven or discontinuous emission. Here we can see that these lines bisecting the Planckian curve represent correlated color temperature, and it's obvious that there could be significant color differences for the same CCT. CRI is similarly misleading. When the CIE created the CRI, it used only 8 colors, a relatively low saturation as the matching criteria, and the viewing instrument was the human eye. There now need to be new metrics and new nomenclature to describe the case that includes discontinuous sources using not direct human vision, but rather the detectors we use, such as film and digital cameras.